6.2, Part 1, Adding and Subtracting Rational Expressions. So basically this is just going to be adding and subtracting fractions with the whole algebra thing in there. So our steps on adding them is first off, and today this isn't really going to be an issue on the ones we're doing, but first off you would get a common denominator if there's not already one there, and we'll talk later about how to get a common denominator. Once you have a common denominator, the second step is to add or subtract the numerators, and that depends on whether it's an addition problem or a subtraction problem. Addition, you add; subtraction, you subtract. You leave the denominator alone, though, and so you have to remember like what you learned a while ago. If we're adding a fourth and a fourth together, we get 2/4. We don't change the denominator whenever we're adding fractions. We just change the numerator because we say 1 plus 1 is 2. And so we have 2/4. Think of it like if you have a 4th cup of sugar, in a recipe, and then you have another 4th cup of sugar in a recipe, and you add those 2/4 together, you have 2/4. That's what's going on there. But we'll have some algebraic expressions instead of just simple fractions like this. So the third step will be to factor if possible so that the answer can be simplified. So let's see how to do this. Example 1. We are going to add because right here in the middle we've got a plus sign. And so we look at this, and now on this first part all of our fractions will have common denominators already. So see how it has 10x on the bottom of both of these fractions? That means that we can just right away do on top 12 plus 3 and give it that denominator of 10x. And we would look at this, and since we can add 12 plus 3, we're going to go ahead and do it. 12 plus 3 is 15 over 10x. And then we want to see if it's possible for us to simplify. If I have 15 over 10, and I just ignore the x, 15 over 10 you can simplify by dividing by 5 on the top and the bottom. So that actually gives us a 3 on top, a 2 on bottom, and then that x remains on bottom where it was. So that this is our simplest answer, which is what we want. Example 2 looks a bit trickier maybe because of our denominators. They're still the same though. We still have denominators that on both of these are the same. They're both y squared minus 16, and we're adding in between. So we need to do y squared plus 16 minus 8y. The plus in the middle means that we're not going to change any signs in the second fraction. And then on the bottom we have y squared minus 16. Well, when we actually work this out, because now we need to check to see if we can simplify, on top we need to rearrange that probably so that it's in standard form, because now you might be able to say, hey, I should be able to factor that. There's 3 things on top, y squared, y, and then a number. So we want to know what multiplies together to get 16 that will add to give me negative 8. So if we think about that, 16 is 1 times 16, 2 times 8, 4 times 4. Looks to me like 4 and 4. So since it's negative 8, we want to make it minus 4 for both. On the bottom here, we can factor as well. There's 2 terms. They don't have anything in common, but if we see we can square root both of them, then we know that we can split that up into y plus 4, y minus 4. And the 4 is there because that's the square root of 16. And so cancel out what is in common on top and bottom, and this simplifies to be y minus 4 over y plus 4. Now, there's going to be problems that we do like that where we're adding where we have a common denominator, but we're also today in this assignment going to work on just finding the least common denominator, not actually adding the fractions with them, but finding least common denominator. So the steps for that is write each denominator as a list of its factors, and then the least common denominator will contain the factors of each. So we want to finding the least common denominator. So let's look at an example just with numbers here. If we have 24, we basically can come up with a factor tree of what multiplies together to get 24. It may be a while since you've done a factor tree, but you split 24 up into two things that multiply together to get 24, and then you split anything you can on that row up, and you just keep splitting up. So 24 is really 2 times 2 times 2 times 3, because that's these last things on our tree. 20 splits up into 2 and 10, 2 and 5, so that's 2 times 2 times 5. And so for our common denominator, what we need is, from this fraction, from the first one, we've got a 2, and so basically we can mark off a 2 from each. Then we need another 2, so we mark off a 2 from each. We need another 2. Well, that one is not in common, so we just mark that one off. We need a 3, so we mark that off. We still need a 5 from the other fraction. We already have the 2 2's from the first one, but we still need that 5. So then we would multiply all these together and get 120. So that would be our common denominator that we were going for, was 120. So let's try this with some algebra. And notice we're not actually adding these together, we just need to find the common denominator. So we're going to split up this 50x into its different factors. So 50, we could use 25 and 2, and then 25 splits up into 5 and 5. So 50x is 2 times 5 times 5 times x. 40x squared, and I'm just splitting up the 40 here, even though it looks like I wrote that where the x squared was, comes 2 and 2, 2 and 5. So that's 2 times 2 times 2 times 5. And then x squared, we would split up and make it x times x. So we need for our common denominator a 2, okay? We need a couple more 2's from the second thing. We need a 5, because they both have a 5, but we need another 5 as well. We need an x, because they both have an x, but we actually need another x because the second one has another x. So we need to do 2 times 2 times 2 times 5 times 5, which is 8 times 25, which is 200. X times x we can combine back together to get 200x squared. So our common denominator would be 200x squared. I actually think it's a little bit easier whenever we deal with stuff like on example 5. We have to factor, which makes it a little tricky, but x squared minus 9, remember, factors into x plus 3, x minus 3. The second fraction here is already factored. If it wasn't, we'd try to factor it. And so both of them have an x plus 3, so our common denominator needs x plus 3. But then this one has x minus 3, so we need to add that in there. And this one has an x, so we need to add that in there. And generally we'd put the x at the beginning because it's by itself. But that's that common denominator right there.